minimum number of removals to make multi-array. So let's first try to understand the problem. So we are giving an array, so the length of the array is going to be more than and equal to 3. And we just want to check if this is going to be a multi-array. So the idea is that this kind of array is going to be a multi-array. So this means we're going to find some index I, and this I is going to be more than 0, less than n minus 1. So the length of the array is going to be n minus 1. So this is n minus 1, and this is 0. I is going to be in between 0 to n minus 1, but not included. So if it is something like this, it is increasing to I and decreasing to n minus 1. This is going to be a multi-array. So we're going to return the minimum number of elements to remove to make nums a multi-array. Yeah. So for the first example, it is 1, 3, 1. So it is a multi-array. We don't need to remove any numbers. So it's going to be 0. Now let's just check the second example. So inside the second example, if we remove indices 0, 1, and 5, so for the array 1, 5, 6, for example, this is 1, this is 5, and this is 6, and then 3 and 1, this is 3, and this is 1. So this is going to become a multi-array. Yeah. So the minimum removal going to be on 3. So how can we solve the problem? So is that clear enough for us to solve the problem? Yeah. So it's very clear. We're going to solve it by using the longest increasing subsequence. So for the first part, so if we want to make a multi-array, so for the first part, it's going to be from the left side, from the left corner to the midpoint, to the highest point. It's going to be here. We just need to check the longest increasing subsequence. Yeah, and from the right side, we just need to reverse it. So if we reverse this line, so it's going to become this. And then we're going to continue to check the longest increasing subsequence. And then we just need to use some very basic mathematics skills to calculate it. Yeah. So let me use an example, maybe the first example. Yeah. So we have 1, 3, and 1. What are we going to do? We're going to enumerate all the numbers. Definitely we don't need to enumerate the first and last number, because definitely it is not a multi-array. We're going to enumerate from the second number. Yeah. So we're going to enumerate this number 3. So for the first part, 1, 3, it is a multi-array. It is in increasing order. So 1, 2, 3. So the longest increasing subsequence is 2, right? And then from the right side, it is 3, 1. But we need to reverse it. After reverse, it's going to become 1, 3. So the longest increasing subsequence is going to become 2. Yeah. Now how can we calculate it? Because for the left side, how many elements we need to remove? Because from 1 to 3, the length is 2. So 2 minus 2, it's going to become 2 minus 2, it's going to become 0. So this means we don't need to remove any element. But what about the right side? 1, 2, 3, and 2 minus 2, it's going to become 0. This means also we don't need to remove any element. So this means we're going to return the answer, which is going to be 0. Yeah. So this is just the calculation. Yeah. Maybe I just need to start coding to explain a little bit. Maybe here we have another element. This is 1, 3, and this is another element. Maybe this is a 4. Yeah. So 4 should be higher. Should be here. Yeah. So definitely we need to remove element 4. Let me make it better. Yeah, so for example, this is 1, and here, yeah, let me make the drawing better. So it's going to be something like this. Yeah, so for this number 3, this is 4. Yeah, so if we're going to enumerate this number 3 at this place in here, so for 1, 4, 3, definitely we need to remove this number 4. Yeah. So for the right side, the longest increasing subsequence is 2, but the length of the array from 1, 4, 3, it's going to be 3. So 3 minus 2, it's going to become 1. So this means we need to remove one element. But for the right side, it is 1, 3, 1, 2, 3. We don't need to remove any element, so we're going to return a 1. Yeah. I think now it should be clear enough to start the coding. But here comes the problem. If we are going to calculate the longest increasing subsequence, normally it's going to be n squared. And then we enumerate all the numbers, it's going to be another n. So n cubic, definitely it didn't work, because n is 10 to the power of 3, it didn't work. Yeah, but we can use a trick for calculating the longest increasing subsequence, which is going to be n log n time. Yeah, and then we're going to time another n, so it's going to be n squared log n. So now it works, because it's going to be 10 to the power of 7 for the final time complexity, so this one is going to work. Yeah. So first of all, let's just try to define a function. I'm going to call it longest increasing subsequence, and inside I'm going to give a nonce. I'm going to prepare an empty array. So this is the greedy idea to solving the longest increasing subsequence problem. Yeah. So for any number inside the nonce, we're going to use a bisect left, because it is strictly increasing. And for this f and for this number, if I equal to the length of the f array, so we're going to append it. Otherwise, we're going to insert it. We're going to insert this number. And finally, we're going to return the length of the f array. So this is going to be the longest increasing subsequence. Now what are we going to do? We just need to enumerate all the possible cases. We're going to prepare result as our final result. And n going to be length of the nonce here. Yeah, even here we use n, but this is the inside function, it doesn't matter. But here is the outside function, it should be okay. It is okay. Yeah. As it is guaranteed to have an answer, so this n this result we're gonna set it to infinity. It is okay, because finally we're gonna have an answer. Yeah. Now we just need to enumerate all the possible cases. So for I in range from 1 to n minus 1. And we just need to update the final result. It's going to be the minimum of the result. Now it comes to the calculation. After the calculation, we're going to return the result. Yeah. So how can we calculate it? Let's just prepare two variables a and b, because we need to check these two variables a and b. A is going to be the longest increasing subsequence from the left side. Let me make a better drawing. So if it is like that, so if this is the enumerating point, yeah, it is here. It is here, yeah. So A gonna be from the left side. We are calculating the longest increasing subsequence. B gonna be the right side. What are gonna be the longest increasing subsequence from the right side? And in this way, we just enumerate all the possible cases. So yeah, let's just use the function LIS with nums to I plus 1, because here is to I. And for B, similarly, we're going to use the nums I to the right side. Yeah. Now for here, we just need to find the final result. It's just some mathematical skills, so we can calculate it directly. But how can we calculate it? So from the right side, it is I plus 1. So for I plus 1, it's going to be the length from the left side, and we need to minus the longest increasing subsequence, which is A, and then we need to plus the right side. Yeah. For the right side, what about the length? So the length is the length is B here. Yeah. So what is the total length? It's going to be n minus I. It's going to be n minus I. So for example, this is our enumerating point. It is 3, and for the right side, it has a length of 2. So 3, the length, minus the index I, 1, it's going to become 2. And then we need to minus the longest increasing subsequence, which is going to be B. Yeah. Now let me just submit it to check if it works. As you can see, it didn't work. For the first one, the second one, it didn't work. Yeah, this means our calculation is not right, definitely. So what is wrong with the calculation? So from the left side, yeah, let me just prepare the drawing. So this is I, and this is a 0, and this is n minus 1. Yeah, this is for the index. So from the left side, for this I, how many elements? Definitely it's going to be I plus 1, and we're going to minus A. A going to be the longest increasing subsequence, which is going to be, yeah, it's going to be 2. So 2 minus 2 going to become the 0. So what about the right side? It's going to be n minus 1 minus I. It's going to be n minus 1 minus I. Yeah, so for example, this is a 2, and this is a 1. 2 minus 1, it's going to be plus 1. It's going to be n minus I plus 1. Yeah, so here it's going to be n minus I plus 1. And then we need to minus this b. Yeah, so this is n minus 1. N minus 1 minus I plus 1, which is going to be n minus I. Yeah, and then we're going to minus b. But we need to, finally we need to plus 1, because this is the duplicate for this point. Yeah, so here we have a duplicate while we are calculating. While we are calculating for the left side or for the right side, we have a duplicate point. We have to minus yeah, now let me just run it. I did something wrong. We have to minus this one, and minus b, and minus 1. Yeah, it is a lot of calculation. Yeah, now as you can see, it works. But let me just submit it to check if it can pass. Yeah, but it didn't pass for all testing cases. It means something is wrong. And for this A and B from the left side and for the right side, we have to check. It has to be at least 2. So this means we have to check. It's gonna, if A more than 1 and B more than 1, this means for the length at the left side and the right side, it has to be more than and equal to 2. It didn't work. Yeah, let me just check. Yeah, I think there's some calculation. Let me just check what is A and B for the left and the right side for the first example. I don't know. It is 2 and 1. Definitely it is wrong. It should be 2 and 2 for this A and B. This is 2i, and here yeah, we can use this I, but we should know for this A and B there is a duplicate. Yeah, this is because I forgot to reverse it. I need to reverse it from here. Yeah, now let me just run it. Now for this A and B it should be okay. At least for A and B it is 2. For the first example, it means my calculation is right. I forgot to reverse it, because for the right side we are calculating the longest increasing subsequence, and for this part we have to reverse it. Yeah. Now let's just go back to the mathematical calculation from here. So for this a and b, it has to be more than 1. If it, yeah, for example, from the left side and for the right side, for the longest increasing subsequence, it has to be more than 1. It means more than and equal to 2. So let me just make it more than and equal to 2. And also for the b, more than and equal to 2. Yeah. Now let's just go back to the mathematical calculation. So what I did wrong. So this is a 0, this is a n minus 1, and this is I. So for the left side, how many elements at the left side? It's going to be 0 to I. It means we're going to have I plus 1 element. And what's going to be the longest increasing subsequence? It's going to be A. So I plus 1 minus A. So I is 1 minus 1 minus A is 2, so it's going to be 0 for this part. So what about the right part? What about the right side? So this is n minus 1. So n minus 1, we're going to calculate in the length. So minus I plus 1, and what's going to be the length? It's going to be n minus I. So n minus I is going to be the length. So this length gonna be 2. 3 minus 1 is going to be 2. And this 2 need to minus b. And this b is going to be 2, the longest increasing subsequence, which is also 2. Yeah, so we don't need to minus this one anymore. Yeah, now let me just remove this one because we don't need to, yeah, minus another one. Now let me just run it. Yeah, now as you can see, it works. Yeah, I think if we understand the mathematical formula about this one for the left side and the right side calculation, basically it should be okay. But sometimes it's also easy to make mistakes. Yeah, so we have to be clear. So this is I plus 1 minus A. It's going to be the length from the left side. And similarly for the right side, after the calculation, it's going to be n minus I and minus B. It should be okay. Yeah, but if this B, for example, if n minus I for the right side here, it is a 2 and B is 1, it is okay. So we're going to return a 1. But currently for the first example, it is a 0. Now let me just submit it to check if it can pass for all testing cases. Yeah, as you can see, it passed for all testing cases, and it is a little bit slow because we used n square and log n time for the time complexity. But anyway, it works. It is 10 to the power, time complexity is 10 to the power 7. Yeah, but this is really easy to think about and really easy to do. I think that's all about it. Thanks for watching. See you next time.